Okay, I think we're live here. Okay, welcome everybody. This is our 6th installment of the past Facebook Live series. This is Pop-Up Experts. And in this session, you'll have the opportunity to ask me any of your SQL Server internals questions live, and they will then be presented to me. I will warn you that sometimes I can talk a lot. So if someone asks a really juicy question, I could end up like taking 15 minutes just to answer one question. But I'll try not to do that because I want everybody to have a chance. If you have a question you'd like to ask, you can type it into the comment section and they'll appear on screen as the moderator presents them to me. So I have been working with SQL Server for a very long time now, over 30 years, and I was invited to participate in the original planning meeting for the International User Group, which I was on the committee that decided to call it PASS. So you can thank me privately or not thank me if you don't like that name, but I have been involved with the organization since before its founding, before the first conference. I've attended every single one of the past summits with one exception. I didn't make it to the one in Charlotte, North Carolina, but I have been to every single other past summit, including the couple that we had in Europe about 10 years ago or so. My specialty within SQL Server is internals. So just basically the way SQL Server works within that area. I love questions about indexes. I love questions about query tuning, query plans, also about concurrency, about locking or no locking, as is done with the new in-memory OLTP. So I hope to see many of you at the past summit, which is in just a little over a month from now. If you see me there, please feel free to just stop and say hello and say, I saw your pop-up expert presentation or your broadcast. And if your question didn't get answered and you have another one, please feel free to ask it if you run into me. If I'm right about to start my session there, we might have to delay, but I don't mind receiving questions at all. I may or may not answer them on the spot. So let's see what questions you've got for me today. Ooh, somebody wants to know about SQL Server 2019. This is an extremely timely question because this week, the Microsoft Ignite conference is going on in Orlando, and they've made a lot of announcements about the next version of the product. I just downloaded a white paper about it earlier in the week, and yesterday I downloaded the CTP2 and actually installed it. So I've run one query so far on SQL 2019. It's a little early to talk about a favorite feature, but I'll tell you, reading the white paper that just is a high-level look at the new features, my focus, of course, is the core engine itself, and it looks like there's some really nice changes to column store index management that prior to this point, there was nothing automatic as far as maintenance of your column store indexes, and that looks like that's changing in 2019. So I'm really excited to see the details of exactly what maintenance they're going to do, but based on what I've seen so far in my particular focus area, I'd say that's one of my favorites. So what would you like to know about the way SQL Server actually works? Do we have any other questions out there? Okay, well, some of you are aware of the fact that I've done a lot of writing about SQL Server. So my next book is unknown at this point. I used to write the great big thick SQL Server internals books, but it turned out that those take a really long time to get out. The last one I wrote for SQL Server 2012 took over 2 years to get out. And when Microsoft is making new releases of SQL Server more often than that, it makes it a little hard to do those big fat internals books. So I've done a couple of smaller books for Redgate. I did one on concurrency. I did one on in-memory OLTP, and then I updated it So my next book will be another one of the short, very focused books. And the topic that I'm considering is about plan caching, managing plans in cache when they're recompiled, when the plan is reused, and how that relates to plan optimization. So when it's coming out would probably be like sometime after it's written. But that's the topic that I'm currently considering for the next book. If you've got other ideas of short, focused books you'd like to see, I'd love to see ideas. So let me know, and maybe I'll change my mind. What else would you like to know? Okay, Mohsin Khan. A newer version of my internals book. Okay, well, I sort of just addressed that. It just takes too long to get those big fat internals books out. If you have a favorite section of those books, a favorite chapter that can be turned into a short book, that would be a possibility. As I mentioned, I had a shorter book just on concurrency, and that's one of the chapters in the big internals book. But it just takes too long to get those big books out, and the product is changing. Not only are we getting big new versions really frequently, at less than every 2 years, but with the way that SQL Server Azure works, they're adding new features all the time on the Azure platform. So any book I wrote would be completely out of date before it was even published for those people that are running an Azure SQL DB. So that framework, that mode of producing information just doesn't really work so well anymore. But if you've got specific topics, I'd be happy to look at them and possibly do a shorter book on a specific area within SQL Server internals. But thanks for asking. Okay. How often should indexes be defragmented? And this is a really common question. I see this all the time. And you might have seen this also, that people make recommendations about when you get more than 25% or 30% fragmentation, you should defrag, or you should run a script that defrags every night. Let me back up a little bit. This is actually one of those questions that I could talk about for the whole half an hour if I wanted to. But let me just tell you a little bit about the way that I see fragmentation, what it's all about, and why it can be a problem. Fragmentation basically means that the physical order of the data doesn't match the logical order. So what does that mean? The physical order is how the data is actually stored in your database files. So the files are broken up into pages. The pages are all numbered, page 1, page 2, page 3, up to however big your database files are. The logical order basically means according to the index key. So if you have an index, let's say on a name column, the data will be logically sorted according to the names. The A's are first, then the B's, then the C's. And logically sorted means there's pointers that we can get to the data in order. So the first page has the A's, and that points to a page with the B's, and that points to a page with the C's. But what's the physical order? If the A's are on page 100, and the B's are on 101, and the C's are on 102, then the physical order and the sorting or logical order match. But if the A's are on page 100 and the B's are on page 4060 and the C's are on page 62 and the D's are on page 311, in order to follow the data in sorted order, we're jumping all over the file. The logical and the physical order don't match, and that's usually what we mean by fragmentation, that the data is not physically stored in the sort order as defined by the index. So the next question then is that a good thing or a bad thing? And of course, it's a 2-word answer. You know what that 2-word answer is, right? It depends. So it depends on what kind of queries you're running. If you're trying to return the data in sorted order, then having fragmented data can really slow down your queries. But if you're just looking for individual rows, select where name equals Macmillan, select where name equals Zoricic, select where name equals Adamson. SQL Server with a good index can find any data as quickly as any other data, and it doesn't matter where it exactly is stored and whether the A's are next to the B's or next to the C's. So it depends on what your queries are if fragmentation is a bad thing. The way to know if fragmentation is a bad thing is in a test environment to run the defrag or an index rebuild command and see if there are queries that perform better after removing the fragmentation. I will say that I see many, many cases where people have regular defrag jobs that don't change any performance. They think when fragmentation gets over 25 or 30%, they have to go through and defrag, and then nothing is improved because of that. So how much fragmentation is too much? It's too much if it affects the performance of your queries, and the only way to really know that is to remove the fragmentation and see if there are queries that perform better. How often should your indexes be defragmented? Well, as soon as they start slowing your queries down. And I know that isn't absolute answers like a lot of people are looking for, but again, I want to stress, not all fragmentation is going to hurt you. Usually it's just if you have queries that need the data in sorted order, and if the data isn't sorted in the database file, isn't physically sorted, that potentially can slow things down. So you need to test to see if removing the fragmentation will help. So I hope that's sufficient to get started with, even though I didn't give you actual numeric answers for that. So what else would you like to know about? Why does the missing index recommendation? Oh, okay, so you've seen this. When you run a query and in the results window, sometimes there's a little mention of the fact that if you built this index, your query could run so much faster. You've seen that? That actually is a feature that's been part of the product for many versions now, where SQL Server keeps track of what indexes might have helped. There actually is metadata you can look at called the missing indexes or something along those lines. But what the missing indexes is trying to do, what the recommendation is trying to do, is have you build the perfect index just for one particular query. And usually it puts a lot of columns in if your query involves a lot of columns. It tries to put every column in your query in the index, so we end up having what's called a covering index. A covering non-clustered index is an awesome thing for performance. In a covering non-clustered index, SQL Server can satisfy your query just by looking at the index leaf level and never having to go to the data. It's one of the fastest ways to get results. So why don't you always do that? Why don't you always just follow the missing index recommendations? Well, here's the catch. The recommendations are just for that one particular query. And I'm going to guess that most of your applications involve multiple queries. You don't just have one. You've got dozens, if not hundreds or thousands, and a lot of applications allow ad hoc queries. You don't know all the queries that are going to be run. Building an index to satisfy one particular query might not help other queries. Plus, once you've got a lot of columns in an index, the updating of that index can become very expensive. The index maintenance can be very expensive. So I know that's not the question here. The question is just, why does the missing indexes put so many columns in? The short answer is because it's just looking at that one query, trying to come up with a covering index. But I'm suggesting to you that you don't always follow those recommendations blindly. Do at least some basic testing after adding that index. look at other queries that involve that table, and especially update queries, other data modification queries, and make sure that adding this index hasn't adversely affected anything else. It's not always a bad thing to follow the missing indexes recommendations, but don't just follow them blindly. What else would you like to know? Ooh, updating the statistics. Oh, that is an excellent question, Christine. Updating statistics is a big topic. I could probably talk for 10 minutes about that. And it's also very historical, because before SQL Server 7, we didn't have automatic update of statistics at all. I used to work for support for Sybase, which is where SQL Server got its start. And many of our questions that we took as support people had to do with queries being slow because the statistics were not updated, because they never were updated unless you did it. So updating statistics by default happens automatically. You can disable that and do it manually. Statistics need to be updated whenever the data gets modified enough so that you end up getting bad query plans. If statistics are not up to date, SQL Server doesn't know what index would be a good index and what index would be a bad index. There, again, I'm not going to be able to give you any specific numbers, but usually one thing to think about is if you have a query that usually runs relatively efficiently and it involves a table that is heavily updated, if the performance of that query starts to slow down, one of the possible reasons is because the statistics are no longer valid. So if you find that queries are starting to degrade in performance, this is usually one of the things we still recommend, even though statistics are updated automatically sometimes. We recommend a manual update just to see if that fixes things. And if you're finding that you are having to manually update statistics a lot for particular tables, then you can actually create a job that goes in and actually forces the update on a more regular basis. One other thing to consider, if you are running SQL Server 2016, the algorithm changed. If you are running earlier versions, 2012 or 14, there is a trace flag. And do I remember the number? No. It may pop into my brain. This is a pop-up session, right? I may have a pop-up of a trace flag into my brain if I just relax a little bit. But there's a trace flag in 2012 and 2014 that changes the algorithm for when statistics are automatically updated. It used to be that SQL Server wouldn't even consider auto update of the statistics until about 20% of the rows in the table changed. And that's a big number. If you've got a table with 1 million rows, and that is not all that big, you need to update 200,000 of those million rows before SQL Server would even consider updating the statistics. And in my classes, in my seminars, I've got demos that show at a much smaller number how you need to update statistics. Sometimes if only 5% of the rows change, you end up getting bad query plans. So the new behavior in 2016 changes that 20% to make it a sliding scale. The bigger the table is, the smaller the percentage. At 1 million rows, I believe it's about 5%. I'll have to check my notes, but it definitely is a whole lot less than 20%. So if you're not running 2016 yet, which uses the new algorithm by default, you want to find that trace flag. You probably can easily find it in a Google search, but I will also tweet it and blog it. Let me make a note about that, unless it pops into my mind before we're done here. The trace flag for changing stats, or how often the stats are updated. So I hope that at least gives you a start on answering the question, Christine. If you have follow-up, if there's something more specific to know, please ask another question. I don't mind follow-ups. Okay. Oh, and I was just told we can post a comment. We can post in the comment section afterwards. So if you come back and look at just the Facebook entry for this session, we can have comments that list the trace flag. That's a great place to put it. So I will do that. Another question from Mohsen. Okay, he says, I saw the cover page of your in-memory OLTP for 2016, but Amazon doesn't seem to have it on display. 2016 is the latest. There have not been a whole lot of changes in in-memory OLTP since 2016. There were a lot between 2014 when the feature was introduced and 2016 when I updated the book. So the next edition of the book is a good one to get if you're using or interested in that technology. But there haven't been a lot of changes in memory OLTP since 2016. I have no idea why Amazon might not be displaying it. But you might want to just go straight to Redgate. Redgate is the publisher. They have their own bookstore. Not only can you buy the book itself, but you can also download for free a PDF copy of the book. So if you just want to read what's new in 2016 for in-memory OLTP, Redgate will let you download the book in an electronic form. So feel free to do that, or you can buy a hardcover, I mean not hardcover, but buy the actual physical book directly from redgate.com and then look for their bookstore. So thanks for asking that. Okay. Oh, okay. I was wondering if anybody was going to ask anything about locking. No lock, though, isn't about locking. It's about not locking. Well, not completely. No, if you're just selecting data, is there any harm in using no lock? Well, that's sort of a trick question because you can only use no lock if you're selecting data. No lock is not applicable to data modification operations, inserts, updates, and deletes. No lock doesn't work. No lock is only if you're selecting data, and what it means is that SQL Server will not acquire shared locks. There are still other metadata locks that might be acquired, but it will not acquire the normal shared locks when you're just selecting data if you use the no lock hint. So what's the problem with that? Well, what that means is, what no lock means is if SQL Server doesn't try to acquire a shared lock, it won't notice if anybody else has an exclusive lock. That means if somebody's in the middle of updating data, you won't know that. You can actually end up reading data that has not yet been committed. And if somebody is writing a query that they haven't committed, maybe they find that the data is invalid or they made a mistake in their query and haven't committed it yet, you'll see that wrong data when you do no lock. So the question is there any harm? And the answer is there easily could be. No lock basically just gives whatever happens to exist at the time, whether it's committed, whether it's consistent, whether it's meaningful or not. So here's the problem with no lock. Not only will you read data that's been changed but not yet committed, but if you're doing a scan, if your query is reading all the data in the table and you're doing it with no lock, here's something that can happen. You might be aware of the fact that SQL Server can perform an update operation as a two-step process. It can do an update as delete the old row and insert a new row. If you're scanning the table and SQL Server ends up and someone else does an update, that update could end up moving the row. So you're scanning the table, and SQL Server might update a row you've already read and end up inserting it to a place you haven't read yet, and you end up reading it again. This can happen with NoLock, that you read the same row twice if it's been updated by another process. The opposite can happen. You're reading the data, and a row that you haven't read yet gets updated and ends up getting reinserted onto a page you've already read, so you miss it completely. So you can read data that hasn't yet been committed, you can miss rows, and you can get duplicate rows, read the same row multiple times with NoLock. So I'm not going to say this is always going to happen, but if it's important to you to get correct results, I would be really, really cautious about NoLock. If you insist on using NoLock, just be aware that the data is not guaranteed to be correct at all. If you just need something quick and dirty, which you hope is close to the truth, okay, use NoLock at your own risk. I never want to say never, of course, but I hardly ever actually say it's okay, go ahead and use NoLock. I'm going to say use it at your own risk. Okay, we're actually getting close to being out of time, and I feel like we're just getting warmed up here. Okay, but there are a couple of other questions I see coming in. My favorite third-party monitoring tool. Well, you know, I can't really mention any specific third parties because there's so many wonderful ones out there. They all have their strengths and weaknesses. I've done work for 3 or 4 of them. I've done some blogging for some of them. I've written white papers for others. I did some internal training for one of them. So I'm not going to name any favorites. I am going to say that they all have their strengths. They all have some really good tools, and some of the tools from one company are better than tools for that area. But what I will let this question lead to is what a lot of these third-party monitoring tools are based on, especially if you're looking at performance monitoring, things like who's blocking, who's taking, what queries are having to wait for reads, what queries are having to wait for locks. A lot of them are based on the internal dynamic management objects. So what I want to suggest is if you really want to understand the internals of what these third-party monitoring tools are doing, is that you start looking at some of the dynamic management views, especially the ones that have to do with indexes. There is one that is my absolute favorite as far as having tuning information in the view itself. And a lot of these third-party monitoring tools are built on top of this dynamic management object. It happens to be a function, and it's called, let me see if I can say the whole thing. It's sys. They are all called sys.dm db index operational stats. Of course, there's some underscores in there as well. sys.dm underscore db underscore index underscore operational underscore stats. Look that up in the documentation. It returns an enormous amount of information about who's waiting for locks, who's waiting for IO, who's doing scans, who's taking how long queries are taking. And a lot of the third-party tools are actually built on top of that view. So take a look at that yourself, and you might be able to write your own third-party monitoring tool. So it does look like we're just about out of time. I will post some additional information in the comments. I'll find that trace flag about statistics updating. I will post the name and the link to the documentation for that dynamic management object I mentioned. And I would like to thank you all for joining me today and participating in the past Facebook Live pop-up experts. And you can follow this Facebook page for updates for this particular presentation and for future presentations in this series. If you're not already a member, excuse me, I didn't quite get through without coughing. Make sure that you go to the PASS website, sqlpass.org. You can join for free and get all kinds of useful information and find out about local events as well as the international events. You can share and learn. There's other online events from past as well, and a host of educational resources. No cost for any of the resources, no cost to join. Excuse me. So again, I want to thank you very much for being here. You can find me on Twitter as Sequel Queen, and feel free to make any comments or questions there. I'll answer what I can, or I'll point you somewhere else. Thank you very much for all of your time, and it was great to be here and talk to all of you. Thanks.